in Communication IoT Technology. From third year IoT, Vipin will start.
Good morning, whatever present here. I am going to explain about data transmission techniques and protocols. Data transmission techniques, it is nothing but a strategy used to deliver the digital form of data from one place to another place. It is calculated by the 1 bit per second. How many bits are traveled within 1 second? Why data transmission matters in IoT? Because data transmission is the backbone of IoT systems, and also IoT devices constantly receive and transmit data from the sensors and the controllers. Next, efficient transmission, because we want efficient transmission in IoT for data sending and receiving and processing. So next, performance, low latency, less power usage. Next, this slide will be classification of transmission technique will be explained by Satyesh.
So there are classification of transmission techniques. Here, direction based are simplex, half and half duplex and full duplex. And timing based is synchronizes and asynchronizes. Path based is serial, whistle and parallel. So synchronizes and asynchronizes means synchronizes where two user and sender who connects at the same time is called synchronization. If not, that is asynchronization. And serial and parallel will be explained by Lakshmi.
So serial transmission. For example, let me take an example first and explain it. USB. In a single wire, you get bits transmitted, right? That is single transmission. A single line transmission, bit by bit, is called single transmission. Here, serial transmission is the method of transmitting data and is sent sequentially, one after other over single communication channel. It is widely used communication between microcontrollers and peripheral devices due to its simplicity and low cost. Bits transmitted one by one, and wiring. Single wire is used for transmission. Speed, it is very slower than parallel for short burst. For example, I said USB. The advantages, due to the usage of one single wire, it is cost effective, suitable for long distance communication, and reduced cost of. There is no interruptions or crosstalk. Use cases, communication between sensor and microcontrollers, as I said before, and remote sensor data logging. Disadvantages are due to its single wire transmission, it is very slow compared to parallel, and slightly more complex timing required. Transmission nodes, asynchronous, no clock, synchronous clock. Next will be explained by Rena.
Myself Vedikava, and today I am going to explain about parallel transmission. Parallel transmission is nothing but when two or more communication takes place at a time simultaneously, each across its own dedicated channel or wires. It entails by the 8 bytes. The word to be sent in a single clock cycle. It is in the short distance and also in the high speed, which plays in the UPS and RAM memory. And the key features of parallel transmission are multiple bytes sent simultaneously on separate lines. Wires are multiple wires because at a single time multiple communication takes place. So we need multiple wires. So speed also faster over small distance. Only in the small distance the parallel communication can be taken place due to the efficiency. And examples are data buses and printed ports. And here the advantages and disadvantages of parallel transmission. The advantages are faster data transmission for short distance, immediate multi-byte communication, simple timing control. Since it is parallel transmission, it works only for short distance. If it is in a long distance, it won't be that much efficient, and it consumes high power, and it is also expensive because we use wires are too much. Use cases are internal processor to memory communication, vary in field IoT application due to wire binding. The transmission modes are simplex, half duplex and super duplex. Simplex is nothing but if only we can send the message where we cannot give them a written message is simplex, and half duplex is nothing but only one person can communicate at a time, and full duplex is where both sender and receiver can communicate at the same time. And next slide will be continued by Umar.
So this is the comparison between the serial communication and parallel communication. So the features is in serial, it's the speed is moderate, but in parallel it's more faster and more advanced. The distance is longer in serial and in parallel is shorter. So what basically is that in serial communication it's like less cost effective, but it's not as advanced as parallel, and it's also more focused towards IoT based devices. So the cost is lower in serial as I told, and in parallel it's more higher as it's more advanced, and complexity is low and it's higher in parallel, and IoT preference is in serial is more as it's cost effective also, and most of the and as IoT requires long distances, so it's more preferable in serial communication, but in parallel it's used very rarely and not usually. So synchronous transmission. Synchronous transmission is a method of data transfer where data is sent in a continuous stream, synchronized by a shared clock signal between the sender and receiver. So the name synchronous itself consists of sync. So what it requires is both the sender and receiver to be synced simultaneously at the same time, so that the data can be transferred from both ends. And the key characteristics are the data sent in sync with the clock signal. There's a time limit for the data. The data should be continuous in flow with timing coordination. Thus as I told, the time should be coordinated between both of them. And the example are SPI and I2C. So the advantages are it has high data transfer speed as both ends are sending data simultaneously, and examples are like in real time it's like Zoom meetings where both the sender and receiver are sending data to each other at the same time, and also it's ideal for real time and continuous communication. Like during the COVID time we had our Zoom classes and online meetings. So the disadvantages are there is loss of data during the process, and also it requires precise timing, so which is not adequate for the process to end. Asynchronous transmission. Asynchronous transmission is a method of data communication where data is sent one byte or a character at a time with each unit framed by start and stop bits without using a shared clock between sender and receiver.
Thank you for giving the opportunity to present the case.